Welcome. This is another live CSEC math class. It's Algebra Tuesday night, Algebra night. So tonight we're going to be looking at laws of indices. Now we have done these laws before, but it never hurts to do them again. We haven't done it on a live session. We do have videos uploaded with laws of indices, but not live. So this is our first live session for the laws of indices. Please don't hesitate to post your questions, post your comments, post your answers. And before we get into that though, I am going to ask you to watch our schedule of live classes so that you'll know when we do what. So here is the schedule. Hello CSEC math students, I know you are busy preparing for your math test and your CSEC is coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand. Okay guys, so welcome back. Let me see who is in studio. We have Imani, John.
Good night, miss.
Good
And
night. Oh yeah, sorry.
No.
Good night.
was that on? Good night, miss.
Good
And
night, Mr. Asar. Miss, we're here saying good night the entire time.
Huh?
Miss, we're here saying good night the entire time to you and Asar. But it wasn't working.
You're here what?
miss, we were speaking, but I don't think you were hearing us.
No.
Oh.
You're just chatting up almost saying
Who's
good night.
shutting off the mouth?
Well, if him say one of that chat off on the mouth and that chat off on the mouth.
No, miss. I literally just said good night, Miss Anasar. I didn't say nothing else. I wasn't saying anything else.
Story come to bomb. Story come to bomb. Well, tonight we are doing a pretty simple and straightforward topic. And you know how it goes when we get to these simple and straightforward topics. We just keep them simple and straightforward. We don't try to complicate them, right, John?
Yeah. Miss,
Yeah.
Miss, can you hear me?
Yes, John.
Yes, Miss.
So we're just gonna go through the laws of indices and work a couple examples and go to our beds.
Yes, miss.
So let us share the screen. Because I'm always talking and it's me alone seeing the screen, right?
Yes, miss.
So tell me if you've seen it.
Yes, miss. I'm seeing the screen.
All right. And boy, I mean, know how it looks so blurry, You can make them out?
Yes, miss. I can see them clearly.
Okay. Hi Kareem, welcome. You want to join us in studio? Oh, let me share the link for those who want to come in studio with us. Here is the link. The link, the link, the link, the link.
Miss, I'm writing it down again. I have about three of these in my book, and I write them down every single time.
All the better. You can't have it too many times. You can't have it too many times. This is one of the foundational, fundamental corners of algebra, right?
Yes, miss.
So you have to know your laws of indices. All right, so what we're gonna do at first, we're just gonna look at all of them together, just run through them, and then we're going to look at each one by itself and just work a couple examples just to illustrate or to demonstrate
Yes,
what we
miss.
mean. So, laws of indices, and they are not in any particular order. It's not that you have to memorize that one is the first law, that one is the second law, that no. As a matter of fact, it really doesn't matter the order because what really matters is which one applies to the situation that you find yourself in. And you're going to use it to get yourself out of that sticky situation, right?
Yes,
So we have
miss.
them here in order. So we're going to go from A. So A says a to the power of m times a to the power of n is equal to a to the power of m plus mn. So of course, usually in algebra, when you are looking at rules, laws, we tend to use variables, and then to illustrate it, we'll plug in some actual values. So everything you see here, except for the 0 and the 1, really, variables are being used to represent what would then be real numbers. So then, what we're saying is, if we have a number raised to the power of another number, let's call that number m. So the base is a, the power is m, and we're multiplying another term that has a base also of a and a power of another number n. So in other words, the bases are the same. So whether it's variables you're using to represent the bases or actual numbers, the bases are the same. So when you're multiplying and the bases are the same, you add the indices. You add the powers. Keep the base, so don't multiply the base. Just write back the base, retain the base, add the powers, and you'll have the base to that new power, the sum. B is a similar law, but it has to do with division instead of multiplication. So for B, it says if you're dividing and the bases are the same, you keep the base and subtract the powers. And for each of these, we're going to plug in some values and demonstrate. All right, so if we are dividing and the bases are the same, we keep the base and we subtract the powers. I hear a plop. The plop usually indicates someone has come or gone. Nobody no missing. So where did that plop come from? Everybody's here, no new person will come. Okay. Let's continue then. All right. Suppose we had, okay, if we have a number raised to the negative power, so a number raised to a negative power, we have 1 over that number raised to the power. All right. So a number raised to a negative power is equal to 1 over the number raised to that power. Next, D. So here we have a number raised to a power, and all of that raised to another power. So it's a power raised to a power. In that situation, we keep the base and we multiply the powers. So we keep the base and we multiply the powers. For E, A raised to the M over N. So we have a number raised to a fractional power. When we're raising it to the fractional power, you can do whichever one you want to do first. So you would raise it to the numerator. The one that's up here, you'd raise it to that power. And the one in the denominator, you'd find the root of that. So you'd raise it to the top number. And when you get that answer, you find whatever number is in the bottom. If it's a 3, you find the cube root. If it's a 2, you find the square root, and so on. And finally, any number raised to the power of 0, that answer is 1. Right? So any number raised to the power of 0 is 1. Hold on. And it doesn't really matter. It doesn't matter what that number is. 10 raised to the power of 0 is 1. 200 raised to the power of 0 is 1. A million raised to the power of 0 is 1. All right, so let's look at them separately now. Okay, so we have someone joining us. We have Kareem. Welcome, Kareem. Can you hear us? Kareem, test your mic. Tell me if you're hearing me. Okay, no sound from Kareem. Can try back. So let's go. So the first one, we're multiplying. We're multiplying. The base is the same. We keep the base and we add the indices. So let's look at some examples. All right, so let's start with Imani. Let's say we have 3x
Okay, miss.
squared times 4x to the third power times 5x to the sixth power. What would that be?
So, miss, we would multiply the whole, not the whole, but the coefficients first.
Okay.
So 3 times 4 is 12, and 12 times 5 is 60.
Alright, so we'd have 60.
And we would put back the x since they all have the base of x.
Okay, so all of them have the base of x, so we keep the base.
Yes,
Uh-huh.
miss. And we add the top numbers. So it would be 2 plus 3 plus 6. And that would give us 60x to the 11th power.
Okay. So we multiply the coefficients, keep the base, add the indices. That's what you're saying, right?
Yes, miss.
All right. Asar, suppose we had 2p q to the third power times p squared q to the fifth power times 6 q to the ninth power. What would that give?
Me, miss?
Asar,
Oh, okay.
Asar, are you there?
Yes, miss.
All right, so what would this one give?
Miss, that would give two, 2p is at 2 at the top of the second p.
Hmm.
2p to the third power.
Would it be a 2 in front?
Oh, 12p to the second power.
Where the 12 come from?
2 times 6.
So multiplying the coefficients, 2 times 1 times 6, and that's 12. All right, so for the p now,
So that's 1
so this is
plus.
p to the first power, and we have to remember that because even though it's not there, we have to add that 1. Okay, so go ahead, Asar.
So that's 1 plus 2
So we have 1
plus
here plus 2. So that's what? P to the
3.
third power. And then Q to what?
3 plus 5 is 8 plus 9 is 17. So q to the
So,
17th power.
so 3 plus 5, 8 plus 9, 17. Q to the 17th power. So this is very important. Remember, we're looking at the bases. We keep the base, add the powers. Once we're multiplying and the bases are the same, so we keep the base, add the power. Remember, when you see a variable in algebra just by itself like that, is really the variable to the power of 1. We don't have to write the 1. We start writing indices from 2 up. But you should remember that it's p to the power of 1 or x to the power of 1. Because remember, We have to add the powers, and if you don't remember that this is a 1, you're going to leave it out and you're going to get the wrong power. So that is very important. All right, John, suppose we
Yes.
had 5
Yes, I'm
a
here.
squared b squared c to the third power times 2 a b c times 4 a to the fourth power b to the third power. Okay, so what would that give, John?
Are you talking about me?
Mm-hmm.
Pardon me?
This is talking about me?
Yeah, see, what's your question?
Is your question, John?
Okay, Miss, we put like term, like term.
We're multiplying.
This one will multiply, Miss will add them. So Miss it be
Yes.
5ab to the fifth power. No, no,
We need to
5ab.
multiply the
Oh
coefficients.
yes, yes, Miss. Oh, okay. So that be both 40, Miss 40. 40
So 5 times 2, 10 times 4, 40. All right, so 40.
Okay. Okay, Miss 40 and B. A, B, C.
You're saying I should write
Oh,
A,
no, no,
B,
no,
C?
don't worry, don't worry, don't worry. Miss, Miss will add the A's together, Miss said, Miss that's the 2, right? Okay, so 2 plus, Miss it be A to the 6th power and B to the,
Oh, you got 6 for A.
Miss because I added the A squared and the A to the 4th.
You
So,
added the 2 and the 4.
yes, Miss. That's how I
And
got this.
you forgot what I just said, that this is A to the first power.
Oh, yes, okay. So Miss A to the 7th power.
Okay. And
And
B to
B
what
is
power?
going to mix to the 6th power and C
So
to the
that's
4th.
2, 2 plus 1 plus 3, that's 6.
Yes, Miss.
And C to the what power?
Miss C to the 1. Yes. No,
C, C to the
Miss,
what?
Miss, Miss C to the 4th power.
So B to the 6th. And we have 3 and
Plus
1 4. C to
4.
the 4th power.
Yes.
All right, so that's the law that has to do with multiplying. When you're multiplying and the bases are the same, you keep the base. If there are coefficients, you multiply the coefficients. Keep the base, add the indices. For this rule now, similar rule, very similar, except that it has to do with division. So if you're dividing and the bases are the same, you keep the base and subtract the indices. So Imani, back to you. If I have 42 x to the 8th power, y to the 4th power, divided by 6 x to the 5th power, y to the 3rd power. What do I now have?
Okay, Miss. So that would be, first we're going to divide the 42 by 6. So that would give us 7.
Mm-hmm.
And since we have the same x basis, we're going to subtract 5 from 8, and that will give us x to the third power. And since I have y for bases as well, we're going to put down y, and 4 minus 3 is 1, so we can just put back y.
Okay, so it's y or y to the first power, which we do have to write the 1. So 7x cubed y.
I'm writing. You write it?
A
Yes.
star.
Honey, can I get a towel?
So we have 8.
I'm going to wash my hair because I've been drinking. So you don't love me. Are you not washing my hair for me?
I have a total of. I can make a tea right now. Ask Amari.
Hurry.
All right, that's yours, Asar.
Okay, miss. Oh, 8 divided by 2 is 4.
All right, so 8 divided by 2, dividing the coefficients, we get 4.
And there's a 1 at the top of the A. Oh, 1 minus 4 is negative 3. So,
So to
so,
be
so A is a negative 3.
a to the negative 3.
And 9 minus 6 is 3, so B 3.
So b to the third power. So since this is a to the negative 3, so we could also write it whenever our number is to the negative 3, we could also write it in the denominator. So it could be 4b to the third over a to the third. This is another way of writing this, right? Because remember, we could have expanded this. We could have written it this way. Each of them, we could have written it as a fraction. So a over b to the ninth divided by 2 over a to the fourth b to the sixth. We could write it like that. And then we would cancel. So 2 into 8. So that will give the 4 at the top. And this a cancels. One of that a leave a to the third. And the b to the sixth cancel out 6 out of that b leave b to the third. So say at the top we'd have 4 b to the third, and at the bottom we'd have a to the third. So just remember that a to the, we can write it this way. A to the negative 3 is the same as dividing by a to the third. And we'll get to that right now when we go to C. But John will get his turn first. So let's say we had now 17 a to the third y to the fourth divided by 2 a to the fifth y to the seventh. What would that give me, John?
Miss, can you hear me?
Yes, John.
Okay, so Miss, it says in Miss for the formula, it says when it's the value Miss was supposed to subtract. So Miss it mean
Yeah.
15
No, you
a.
don't subtract
Oh
coefficients.
yeah. Oh Miss it be
Honey, ready?
7.
It will be what?
Miss it be Miss it be 19.
How you get 19?
Oh no. Okay, Miss that way. Miss 17 a to the negative.
17a
Yes, Miss, to the negative second power.
to the negative 2
Yes, Miss. And y to the negative third power.
mhm,
divided by let's I can just go over 2 all right, let's do 2ay.
Or you get more AY.
Oh, don't worry. Okay, Mrs. Say something. I was confused.
So remember we already worked, so it's 3 minus 5 that give us the negative 2. 4 minus 7 that give us the negative 3. So it's 17 divided by 2. We can leave it like this or we can divide it and get 8.5 if we want, right? So remember, this can also be written as, these are to the negative powers, so they can go in the denominator. We can rewrite them in the denominator. So it will be 17 over 2a squared y to the third power. We could write it like this, 2. So just bear that in mind. Bear that in mind. If we want to write it in negative index form, we can. If we just want to write with all positive indices, we'd have to put those now in the denominator. All right. So let's go now to the rule that says any number raised to a negative power, it can be rewritten as 1 over that number raised to the positive power. So you can write it in terms of numerator, denominator, or you can write it in terms of negative power, right? All right, so if we had then 2 to the negative 1 power, Imani, that would be what?
Okay, miss. So, oh, wait, give me a second, please, miss. I'm writing down the question. 2 to negative 1, so that would be 1 over 2 to negative 1. And
1 over 2 to the negative 1.
oh wait, 1 over 2 to the 1 power, sorry.
Or 1 over 2.
Yeah.
Right? 1 over 2. 2 to the negative 1, 1 over 2, right?
Yes, miss.
Um, so what would be, so Asar, x to the negative 3 would be what?
Means that would be one over x to the third power.
Okay, 1 over x to the third power. And John,
Okay, miss.
10
Miss 10.
to the negative 4,
Okay, so miss do 1 over 10 to the fourth power,
which is what?
which is 1 over oh oh miss 10,000.
1 over 10.
Are you doing?
Okay.
Yes, yes.
All right, so now we're saying if we're raising a power to a power, right? So in brackets, we're raising this term, which includes a base and a power. We're raising all of that to a power. So we keep the base and we multiply the powers. Okay?
Yes,
All
miss.
right, Imani. So let's say we have 5 x squared to the power of 3, what would that give?
Miss that. So that would be 5x to the 6th power.
Mm-mm.
Would
You
it
have
be
to raise the coefficient to the power.
125x to the 6th power?
Right, so raise the coefficient to the power and then multiply these powers for the base. So 5 to the third power would be 125. 5 times 5 times 5. And then we would have x to the
6th power.
6th power. All right. Okay, Asar, because we had negative 2 x to the third power y to the second power 5. What would that give us, sir?
Miss you times is that to the power of 5.
So it will be what?
So we write back the negative 2.
Would we write back the negative 2?
Oh, oh. So
We
it'd
have
be
to
2
raise the
times 2
negative
times
2 to the
2
power of 5.
times 2. So 32. Negative 32.
Okay, so it's negative. So remember, when we're raising a negative number to an odd power, the answer is negative because it's going to be negative 2 times negative 2, which is positive 4. So we're multiplying negative 2 by itself 5 times. The first two negatives going to give a positive when you multiply them. Then when you multiply it by this, it's going to turn negative. This going to turn it to positive. This going to turn it back to negative. So once you're raising a negative number to an odd number of power, the answer will be negative. All right, so for when the base is x to the third, that's going to be what? No.
X to the third times 1 to the 5th. Oh, that's x to the 8th.
Well, multiply the base, the powers.
Yeah, x to the 6th. X to
X to
the,
the
x to the 15th.
x to the 15 and y
And
to the
y
what?
to the 10th.
Y to the 10. All right, John.
Yes, miss.
So we have negative 4
Good for
a b to the third c to the fourth squared.
okay.
What would that give?
Okay, miss, in the formula it says that we're supposed to multiply the. Is it supposed to be? Okay, in this case, be negative 4a times b to the third times c to the fourth times 2.
No, John. Square the negative 4. That's the first thing you do.
Okay,
Square the coefficient.
so that's really negative 4.
Negative 4 squared would be
Let's have that positive 16.
16. And then now, a to the first power and square that gives what?
This extra. Miss reason a to the first power.
This is a to the first power, and you're raising it to the second power.
It's a squared.
A squared. And for the b,
Miss for b to the third power, to the fifth power. Um, is that b? It should just be b to the fifth power.
you have to multiply the powers, see? Multiply the powers. So it's 3 times 2. For the b, it's 3 times 2. So what's that?
Miss b 3 times 2. Miss that's 6.
And for c,
Miss for c. Miss c to the eighth power.
um, so tell me guys, suppose I had done this. Sorry. Not that color. Suppose I'd given you this though. Like if we had 3x to the fourth y squared, what would that give?
Miss I don't know.
Imani, what would that give?
Miss,
Miss, that
Asar?
would give x. Oh, Miss, that would give
um,
3x to the eighth power, y to the second power.
So why didn't we square the 3?
Miss, because it isn't in the bracket.
Okay. So this time the 3 is outside the bracket. It's not affected by this. All right. Were you saying something, Asar?
I was saying what Imani said.
Okay. All right. So this rule now says if we're raising a base to a fractional power, we raise the base to the numerator, to the power of the numerator, and find the root of the denominator, which it applies. So for example, 16 to the half. 16 to the half is the square root of 16. Because it's really, remember, we would raise it to the power, which is 16 to the first power, which is 16, and then the root of the denominator, so root of 16, and that's 4, right? So you can know, so a number to a half power, find the square root of the number. A number to a 1/3 power, find the cube roots of the number. You can remember those, right? So the cube root of 8 will be 2. It's the same principle, just that it's about 1 at the top. So you're raising the number to the power of 1 and then finding the root of whatever the denominator is. Same principle. So Imani, so if I had 8 to the 2/3 power, what would that be? Imani?
Oh, Miss, I just okay. So I was saying that it would be the cube root of 8 raised to the second power. The
So we
cube
could
root of
find
8.
the cube root of 8 first,
So
which
that's
is
2. That's 2, miss.
2, and then
And then
raise it to the second power,
2 raised to the second power is
which
4.
is 4. Or we could have raised the 8 to the second power first, which is 64, right? 8, 8,
Yes,
64.
miss.
And then find the cube root of 64, which is 4,
Yes, miss.
right? All right. So, Asar, so suppose I had 125 um, to the 2/3.
So root, it's 3 root
The cube root of 125,
125,
which is
25,
cube root of 125 is
25,
no
oh, 5,
5, and then we're going to square the 5.
no, 25.
Okay, so the answer is 25. And John, all right, so if
Miss
I
Ian,
had, hmm?
so that's in here.
All right, John, suppose I had, um, okay, suppose I had 9, or not 9, let's say 9 over 25, mm, to the 3 over 2.
Okay, miss would find the square root.
So square root of 9,
Yes, miss 9 over 20. Make the square root of 9 over 25, miss. The square root is 3 over 5.
okay,
And miss the 3 over 5 times the times 3 over 2, miss.
so we're going to square the 3 over 5, and we're going to get 1.
This one is great. Okay,
Sorry, not square, third power, right?
yes, miss.
Okay. So 3 to the third power,
Miss 3 to the third power. Miss it with 9 over 25 still.
no,
Okay.
3 to the third power,
Oh, yeah. Okay, miss it with 27 over 125.
all right, so 27 over 125.
Yes.
And if it had been to the negative, if it had
Yes.
been to the negative 3 over 2, then we would just invert this fraction here.
Okay, so miss it with 125 over 27 then.
Yeah. If it had been to the negative power, because remember, to the negative mean 1 over the inverse, right?
I always have a
So,
question. Miss, how many
yeah,
questions are there?
this is the last one here now. And we're just going to demonstrate that any number raised to the power of 0 is, so half to the power of 0 is 1. 516 to the power of 0 is 1. Any number, right?
Yes, ma'am.
To the power of 0. 1 to the power of 0 is 1. All right. And that's it. That's it for the laws of indices.
Yes, miss.
All right, so let us go to our beds. Let us go to our beds now.
Yes,
Unless you guys have something else you want to do.
no,
Nope.
miss.
All right, so enjoy your night, and thanks to those in the chat who were keeping us company, even
You're
though you were
welcome.
doing it silently. Thanks, Asar. Thanks, John. Thanks,
Yes,
Thank
Iman.
you, miss.
No problem, miss.
Okay, see you
Bye,
tomorrow.
miss.
I was
Bye,
glad to
sir.
come
See
here
you
last night.
tomorrow.
Bye, John. Bye,
See you
Manny.
tomorrow,
Bye,
sir.
miss.
Bye.
What John said a while ago?
Mr. said I was glad to be here.
Oh, okay. All right. Thank you too. So goodbye.
Bye,
Bye,
miss.
miss.
All right, and here's our schedule. Hello, CSEC math students. I know you are busy preparing for your math tests and your CSEC exams coming up. I have a very important question to ask you. Do you like my new hat? Thank you. Now, another important question. Have you ever gotten a math problem wrong simply because of making one little mistake? I'm sure you have, as thousands of other students have. Now, in this series, we're going to be looking at the common mistakes that students make with all the topics in CSEC Math. We're going to look at the common errors, demystify everything. Make sure you watch every video in this series so that you can avoid making those mistakes. So stay tuned. Hello scholars. Did you know that most times when students get problems wrong in mathematics is as a result of one single error or one mistake? Well, this is absolutely true, and we're going to be looking at the common errors that students make in the different topics in mathematics. If we know the errors beforehand, we can certainly avoid making them. Are you ready? Come on, take my hand.